Okay, so this is really a two-part problem. We have the change in mass and the change in volume. So let's look at the change in mass first because it's a bit easier to look at. So what here would represent a change in mass of the solution as a whole? Well, when we're looking for change in mass, we're really looking for molecules either leaving or entering the solution or whatever system we're talking about. And so what would cause molecules to leave or enter here? Well, there's not really any examples here of molecules entering, but molecules leaving, we should be able to find the culprit as CO2. This is going to turn into a gas, and of course, a gas is less dense than water, so it'll float up to the top and it'll leave. And it says the beaker is left out open, so it'll just leave into the air around. So we know that there's going to be a decrease in mass because we're removing particles in the form of this gas. But how much is that increase or decrease in mass going to be? Well, first of all, let's calculate how many moles of carbonic acid we're starting with. It's pretty simple. We just take 1 liter times 5 molar solution equals 5 moles of H2CO3. Okay. And now we know that since there's a 1-to-1 ratio here, every decomposition of H2CO3 makes 1 CO2, that we have 5 moles CO2 leaving. And therefore, we just need to calculate the molar mass of carbon dioxide. You can do this yourself. It's fairly simple. The molar mass is 44.01 grams per mole. And so we multiply this by 5 moles, and we get a total of 220.05 grams of CO2 leaving. Okay, so that's the first step that we've already solved for mass. So that's part 1. What about volume? Well, remember, in chemistry, we assume that solutes really don't take up any space. They don't. We don't think of them as affecting the volume of the solution. They do very slightly, but we're just going to ignore that here. So we're not losing volume because this is decomposing. When we're looking for a change in volume, we really want to look for solids and liquids being added to this solution because that's what really takes up volume. And we can very quickly look at the culprit here, and it's obviously the water, right? We're adding water to the solution when this decomposes. And so we're going to have an increase in volume. We're going to have a decrease in mass and an increase of volume. How much, though? Well, we're given a density in the problem, and it's a fairly accurate density. Water is pretty much around 1 gram per milliliter. Depending on temperature, it's more or less dense, but we're given here that it's 1 gram per milliliter. So in order to find milliliters, which is volume, we need to find grams. And we do the same thing we did here. The molar mass of water, and you should probably have this one memorized if you don't already, is 18.02 grams per liter, or grams per mole. Okay, and so to calculate grams H2O, we're just going to take 18.02 grams per mole times 5 mole, which is equal to 90.10 grams. Lastly, we have a very nice number that's 1 gram per milliliter, and water's really nice like that, so this also equals 90.10 milliliters. And that's our answer for the change in volume. We're adding 90.10 milliliters to the solution. You could also write this as 0.0901 liters.